Mike, are you able to hear me? Hello and welcome to another BobCAD-CAM live event. Tonight we're going to be going over the Lathe module. We'll get started here in roughly about 10 minutes just for people to join, and we'll get going shortly. All right, again, welcome everybody that's just joined. Today we're going to be going over the Lathe module. Again, my name is Andrew. So let's get started. So a couple of things that I wanted to point out first off with the lathe is you're going to have, excuse me, you're going to have a couple of CAD functions that kind of help you out here. So the first thing I wanted to point out is this turning mode. Now, a lot of people, they'll get a print, it's just XZ values. You just want to enter those values and move along. Well, when you turn on turning mode, it replaces your X, Y, and Z axes. So instead of being on an XY plane, it rotates it to be on a XZ plane. And actually, I shouldn't say rotates. It actually just renames those CAD functions. So if I go to a create 2D function and I go to line, it now says ZXY. If I go back and turn off turning mode, it's now XYZ. So whenever you're drawing for turning, you want to be in the negative X, positive Y, or the negative Z, positive X quadrant if you're in turning mode. This does not affect machining whatsoever, and it actually makes most people more confused. But I did wanted to point out if any of you have any problems drawing without that turning mode on. It does change the axes, so you can clearly put in a distance. So I might have a diameter at 1 inch. So if I enter 1 inch, it's actually going to 1 inch absolute on my screen. Let's just say I go down 1 inch in Z, and we'll say our absolute endpoint is Z0 and X1. Now, if I'm entering that as a diameter, I cannot enter it that way. Bear with me 1 second, everybody. All right, sorry about that. So as I was saying, when you're drawing, say, a line, if you want to enter the actual diameter instead of the radius, what you're going to need to do is up in your settings, and you could also go to File and go down to Settings, but we also have the little button at the top. If I go to my CAM settings, I'm sorry, this is going to be under Current Document and Document Defaults. So current document and document defaults, current document only affects the current document open. Document defaults is for every file that you have not yet opened. So I'm going to just change this in current document. So what this is when I go into lathe coordinates, I can go into diameter mode. This is actually the biggest benefit of the lathe coordinates. So if I apply that, now if I enter the same values for that line, we'll just start at 0 and go to 1 inch. We'll go -1 in Z and 1 inch in X. And that puts it at the radius for that 1 inch diameter. So there's a big distinction when you're drawing what that's going to do. Now, a couple of the CAM functions that really help out. And actually, I'm going to go ahead and open up one of my files here. Just grab this guy right here. If you have a solid model, you can't pick this for any of the CAD functions, for any of the features, any of the tool paths for turning. But we do have 2 functions within the software to help you get wireframe for these profiles. So if I go to my Create 2D tab, I have a section view and spun profile. Now, section view is the one you're going to use for most concentric turning parts. The spun profile is really there for a live tool lathe part that may have hexes, slots, gaps. Now, if you have parts like that or they're non-concentric, that spun profile records all the high points off that model. But there is a downside to it. Before I hit generate wireframe or create wireframe, I'm going to create another layer, and I'm going to call this view or the section view. Now with the check mark on that layer, I'm just going to hit create wireframe, and then we'll cancel. So if I hide that CAD model, it gives me the wireframe of that section view of that profile. Used to be a lot more steps to do this a long time ago when I first started BobCAD, but now it's a little bit easier. Now, the other function to get wireframe from a solid is the spun profile. But what I'm going to do is we're going to turn on the use layer properties. I'm going to call this spun. And I'm going to change the color of it. Let's change this to a black color. Now, as long as I have the use properties, the use layer attributes on, this will come up as a black geometry. So if I go to spun profile under create 2D, I can pick the entire model. Now this does have a tolerance applied to it, so keep that in mind. And if you have arc fit on, it'll create radiuses when it does little line segments, if it can, just like with our fit arc on the toolpath for 3-axis. And I'm going along the x-axis, so down the center here. So I'll hit OK, and then cancel. Now, a lot of people would say, well, this is what I'd rather have, because it's just giving me half the profile, where the section view is giving me the entire thing. Now, I know for a fact this one actually does deviate, and this is one of the reasons I use this file, is the section view is always going to give you the more accurate profile. Or if you can see, my spun profile is giving me a little deviation, and that's where that tolerance comes in. So if you have a concentric part, you really want to stick to the section view function. One of the things with section view, and it actually happens with this part, if I'm not rotated properly, so I'm going to just back up a little bit. We'll turn off other 2 layers there. One of the things with section view that does happen is if I go back and rotate this up, let's see, we're going to go -90 in X. You'll notice the seam of this cylinder is along that axis. Oftentimes when you run into that, when you do a section view, you're not going to get that pink preview. If you don't get that pink overlay, you're not going to get a wireframe. I can hit create wireframe all day long. I'll just create a layer and hit create. It will not actually generate anything. So just keep that in mind. The seam of your model, if it's just a round part, can make a big impact on how that section view is going to work. So you may have to rotate it a little bit to get to the right portion. Huh. All right, 1 second for me. Mike just pointed out there was a little black box there. I didn't see that. I was unaware. So thank you, Mike. I will make note of that. We're a little new to using Vimeo for this, so you have to bear with us on some of this. All right, so to get back to what we were looking at here, so we might as well use this part for some toolpath, some basic toolpath here. So I'm going to just hide that CAD model, and we're going to turn on our section view, since that one is the best one for this function. So what we want to do is we want to split this in half just to make it a little easier for us. So if I go to line, I'm just going to sketch a line right down the middle. And then we'll right click and cancel. Then I'm going to go to utilities, and we'll just go ahead and quick trim these 2 lines. And if I cancel out of quick trim, I can go to my select mode and then just left click and drag a box around the remainder and hit delete. So now I have what I need for this toolpath. Now I am in millimeters, so I'm going to switch that over to inch. And I'm going to go to my cam tree. So I'll right click cam defaults. Now, if you're not comfortable with the right clicking in software, we have a lot of right clicking, but we also have a lot of buttons. We added a lot of options, and that's why sometimes it does look like you're looking at a lot of things going on here. Everything that is in the cam tree is also under the cam tab, like new job. So if you're more comfortable clicking on a button, you also have a button here for new job if you don't like right clicking. I prefer right clicking just because I've been here for so long doing it. So I'm going to go to new job, go down to turning, and I'm just going to use the basic BC2X lathe. Now, the lathe machine, we don't really use that much in the simulation. So your post processor is really the only thing that matters when picking anything. So we'll go ahead and click OK. Now, if I click OK, it's going to start the job. If I had clicked Stock Wizard, it would have taken me to a workpiece selection. I don't need a workpiece, and that usually does confuse a lot of people. So if you're more comfortable, just click OK, and then you can go right to your stock, right click on it, and go to Stock Wizard. You also notice that once I clicked in the cam tree, once I'm on this turning job, I now have a turning tab. So just the same as all the cam stuff is under the cam defaults. Everything that's within the turning job is also under the turning tab. So if you're more comfortable going to the stock wizard up here, it does the same thing. Now the stock for turning, you'll have cylindrical stock and then you'll have revolve stock. Now we're going to look at revolve stock a little bit later for a couple of extra little functions. But I believe this was, if I'm not mistaken, I think it was a 7-inch diameter. Yeah, have no internal diameter. And then the length, I believe it was around 7 as well. Now you have this stock origin here. Now, if you do not put a stock origin in there and you try to face the part off, it's not going to give you toolpath. There's ways around that, but it's best if you're just going to take 20 or 30 thou off to put that in here. And you'll notice that it actually moved my stock forward. So it's still 7 inches in length. It just moved it 30 thou forward. So I'll hit the next button or the forward button. And then you have your machine clearances. So if you have a smaller lathe, maybe you have a part that's close to your full diameter, you may have to change your clearance so that you don't get a over travel when it goes to move the x-axis. I run into that very rarely, but it does happen. Generally, we don't need to change these, so I'm just going to click OK. All right, so now I have my stock. Now the machine setup, if you've ever used mill in BobCAD, it's nothing like the mill or the mill turn modules. It automatically uses the turning mode orientation. So if you notice, I am not in turning mode currently. I have an XY plane because I imported this model in. Again, you don't have to be in turning mode. It is just there as a drawing assistance tool. So I'm going to right click machine setup 1. And like I say, you can also go up to the top. You have all your features up here. And I'm going to go to lathe in face to start. So I'll go ahead and select geometry. Now you don't have to draw any extra dimensions here. If anybody's used BobCAD, an older version previous to 29, I believe, you used to have to draw in the full length of your facing and all that stuff, cover over grooves, and a lot of CAM packages are like that. But you don't have to do that anymore. You just select the face and hit OK. And in actuality, you don't even need to pick geometry. We just automatically go to 0 as long as you have stock defined. So I have my rapid plane, my material approach there. And then I have my feature parameters. So you have feature type is locked out as a front face feature. And then the region is region 1 or region 2. So this is actually the direction of the cut. So whether you're going from OD to ID or ID to OD. Now, if you forgot to put material on the front of your stock, if you didn't shift it out in Z, you do have an option for a custom value for your constraints. If you leave it from stock and you don't have stock there, you will not get any toolpath at all. So if you don't define the face, you can always add your custom value here. Just just pay attention to the value there. It does start at 2 inches. So, and lastly, on this first page, we have extensions. Now I don't need to extend the start, which that is relative to the region. So region 1 comes from the OD to ID. So the start would be on the OD and the end would be towards the ID. So I want to go past maybe, let's say the radius of my tool, let's say 30 thou. I'll hit next. Then we have our machining strategy here. I'm just going to go with the rough and finish. And I'm going to use CAM cycles for this one. It's a very basic facing. So next again. And then we've got our tool. Now the tools, they use all the same kind of definitions that you would buy, any insert. You have your CNMGs. We have all your different shapes in here. You do have your tool crib with your rough, finish, groove, and boring that you can use for this operation. But I'm going to go with the default tool on this one. Just remember, you can show tool holder. So if you're, say, using this tool for a different operation afterwards, you want to make sure it's oriented the right way. And if I'm showing that tool holder, I can show it either vertical or horizontal. So you do have your orientation here. You also have your insert orientation. Now we actually do a lot of work in the background. So if you're on the feature page and you pick region 2 and I go to the tool, now it's an orientation 4. And if I turn off the show tool holder, you'll see the theoretical tip is right there at the top there. If I switch the feature back to region 1 and go back to the tool, it's now in orientation 1. So we automatically figure a lot of that stuff out for you ahead of time. Now I'm going to leave this just the CNMG. Nose radius we'll say is the 15 thou. Actually, let's just make that a 32nd. Added an extra decimal. All right, so we'll go next. Now you'll notice a lot of things are grayed out here. Because I went into CAN cycles, we don't have a lot of these options. So we actually can do a lot more than what your lathe can just with the CAN cycles. So you have your compensation on with and without collision detection. So seeing as this is a facing, I really don't need the collision detection, but the collision avoidance, the collision detection will look at your insert. And if you tell us, we'll look at the holder as well. So if you define them appropriately, we'll actually avoid any collisions along the path. But we'll go without just for faster calculation times. Then we have our depth of cut. Well, it's only really going to do the 2 passes. So because I'm going to leave a finish allowance here. And it's not really going to use the overlap, so I don't need that. And corner type, we don't have any, so we'll hit next. Then we have our rapids. Now I might want to go right to the cycle start just so I can go into the next operation. So in the approach, I usually don't change this too often unless I have a very specific location I need to start from. But on the exit, a lot of times, if I know I'm going to be going and using the same tool for either another operation or for the finish on this, I can go to cycle start. So you'll notice you'll have default, which is just a home position. Now this home position is defined on the tool, which we'll look at a little bit later. Then you have tool home, which essentially is the same thing. You're just defining moving X and then Z, Z and then X, or X and Z at the same time. So cycle start really is the only one that's truly different here, except for the no rapid on exit. So I'm going to move out in the Z and then the X, since I'm doing facing, and then I'll hit next. So we're going to do a parallel lead in, and this image is just an example of what a parallel lead looks like. It's not what it's going to do in this exact scenario. And then the lead out perpendicular is just going to come straight off. Now, a lot of times I will do horizontal because perpendicular with some extensions or lead outs can go kind of crooked. So at least that's happened to me. So if it does, horizontal will force it to come straight off. I don't need the advanced feed rates or the MDI, so we'll just next pass those. And then I've got my finish tool. Now I'm just going to go with that same tool. So I'm going to pick tool number 1. And actually, it's not tool number 1 because I changed the radius. It's tool number 2. Now, if you're in version 35, you can also do that here from this drop-down menu. You notice now I only have 1 tool here because it overwrote the auto-selected one. Then we have our patterns. We're just going to do a continuous pattern. I can do alternating, but on a facing, it really won't make any difference. I'm leaving no allowance, and there's no corners. And then my rapids, I might even want this to go to cycle start, X and then Z, because I'm going to go and do the finish or the rough turn on the OD. Leads, parallel in, we'll do horizontal out. And then we have our advanced feed rates and MDI. So we'll compute. So you can see there's our facing, but I want to maybe use that same tool for the OD. So I'm going to go to machine setup 1 again, and we'll go down to lathe turning. Select geometry. Now, if I click on the first entity, I then can hold shift and click the end of the last entity, and it'll pick in between the 2. So I'll go ahead and hit OK. And then next. Now, when you're doing grooves, it's really important. You have your feature parameters here. I am doing OD, but it's really important I turn on the remove primary undercut. And on this one, because it has the angled groove in the front here, I also need to turn on the remove secondary undercut. Now, the constraints, I am going to go from stock. And extensions, I may want to extend it, maybe 120 thou for a cutoff tool. So then we have our machining strategies. We'll just go rough and finish. And then this time I am going to go separate moves. So a lot of those functions that you saw were grayed out earlier won't be grayed out now, and we can take a look at what those are. So I'm going to go with that same tool. Might as well go ahead and just stick with that one for now. So now it's not grayed out. You have your 2 patterns. You have a standard pattern, which is like your CAN cycle, and you could do a zig or zigzag pattern to that. Same thing with offset. So offset is kind of like your pattern repeat CAN cycle, but we actually trim out the area outside the stock. And you have a zig or zigzag option for that one as well. I found that really works well for like button tools going into deep grooves. I've used that quite a bit for that. Which we could probably use this on the part here. We have those round grooves. So system compensation on without collision detection should be fine. There's really nothing we should be able to hit. Depth of cut, we're going to do 50 thou. Now that's per side. Anytime you're doing a turning operation, it is per side. If you're on a facing operation, it's just a straight value. So anytime you're entering an X value in turning, it's always the radial value, not the diameter. The post handles the rest, whether your machine is in radial or diameter. So finish allowance, I'll leave 10 and 10. I don't want an overlap, but we also do have a chip break. So if I'm going to be doing, and if I go back just to make sure, so I'm doing standard and standard, but I can add a chip break to this. So what chip break does is I can say for every 1 inch of cut, it's going to retract 50 thousandths to break that chip up. Or I can tell it for every 30 seconds engaged, do the same thing. Or every length of chip, do the same thing. So you have a couple different options here. So let's say 1/2 inch, and I retract 50 thou. We don't need the corner type, and then the bounds, we're going to talk about that a little bit later. So we have our rapids. Now I'm going to have this go to cycle start because I haven't changed the tool at all. And this time we're going to do X and then Z. So lead ins will go parallel, and I'll do vertical out. I usually like to stick to straight line moves. I find most lathes are okay with that. And then our basic finish. So I might as well just go with that same tool again. Continuous, you do have an alternating path. Let's go ahead and try this one. There's a couple walls that we can do, not very many. But I'm going to do both. And then the overlap, let's just put that at 25 thou. So what this is going to do is it's going to turn both the diameters and then go back and do the walls going the opposite direction. I want no finish allowance, and I don't need the chip break since this is going to be a little shorter path for each of the cuts. Our rapids, which we can have this go to home since it's going to have to change to something else. And then our lead ins, again, we'll do parallel in and vertical out. And then the last 2 pages I don't need, so we'll hit compute. All right, so let's take a look at what we just did. So let me blank the job. And if I click on the rough for that turning, you'll notice that there's all these little retracts. And if I right click the rough, I can go to backplot. So if you have a hard time seeing stuff in simulation, sometimes it goes pretty quick, which I'll show you how to slow that down. You can go into backplot and actually kind of see what this is going to do step by step. And that looks pretty good. So let's actually just go ahead and simulate that, and I'll show you some of those options. All right, so when you are in simulation, let's go ahead and show my stock. I oftentimes will show a front view and have it fit to screen so I can see the whole thing. Now, the toolpath rendering, this is something that we were actually just talking about, I believe, this morning. A lot of times I will first things first, when I grab the software, I will set this to current op and then go back and set it to segment. So I only see a small portion of what's running. So when I go to the OD, I don't have this mess of toolpath on the screen. That way you're not having to hide the toolpath all the time. Now, the other thing is the mode that you're in. The default mode is in C mode. So when you simulate, even if I slow it way down, every line move is just going to be flying across the screen because it's just plotting the points. The tool is actually not moving across the part. So what I recommend typically, let's go ahead and stop and restart that, is using length mode. So even length mode, maybe right around there, you're actually going to see that tool running through the whole part. So you can see it retracting along that. I might need to increase that retract because that might not actually break the chip. But those are a couple of the settings that I usually do right away when I load simulation, just so I don't ever have to touch them again. I often forget about them by the time we get to a new version. We can see the nice little stair step it's made from each of those paths. and we'll see how the finish takes all that out. And there we go. So that looks pretty good. So let's go ahead and take a look at these grooves. Now, when you're doing a groove, and actually that finish did get out the floor. I was just looking at the rough. Let's minimize these. Now I'm going to right click on machine setup 1, and we'll go to lathe groove now. So I'll select my grooves, and I'm just going to pick both of these. Now, if any of you guys are coming from, say 28 and under, you couldn't do this before. You couldn't pick both grooves. Now you can pick grooves on multiple diameters, different sections like this with no problem. All right, so doing the groove doesn't start out any different than the turning. The only exception is the rotate, which is for angled grooves, which I don't think I'm going to get into today. Already kind of spent a lot of time going through a lot of this stuff, and I wanted to hit on a couple other things. But you do have your feature type, OD, ID, front face, or back face, and then your region. Again, region 1 is from the face to the back, 2 is from the back to the face. Won't really matter for grooving, so I'm just going to go with region 1. Constraints, I'm actually going to go from geometry. Typically when I do a groove, I always select from geometry because I've already turned everything else down. And I don't need extension, so I'll hit next. So we'll do a rough and finish. We'll do separate moves. I'm going to need to. One of the big things about grooving, if you do can cycles here, it's going to make a rectangular bounding box of this area to do the groove. So if you're not using a round tool that actually fits this exactly, it's not going to work. So you have to do separate moves on a round groove like this. Now I'm going to go and get a full radius groove tool, but let's see what I have in my library. I don't have much, so I'm going to go ahead and add a tool. I'll call it round groove. If I can stop hitting extra buttons. Okay. Tool width, we'll just go with the 1/8 inch, and the radius 16th. So we have a full radius on this tool. And then the holder, let's go ahead and we're just going to extend a little bit, maybe make it 1.5 inches. I know we don't need that much space, but I'm going to go ahead and just adjust it a little bit. With grooves, you do have these other tool holder types if you do need. If you also need, you can customize your own. There's a really good help system document on that, which hopefully we're going to be able to touch on creating your custom tools and everything. All right, so I've got my round groove tool. Now, when you're defining the corner, you have your left corner, tip, or right corner. And for turning tools, I didn't go over it. It's corner, tip, or center, which is center of the radius of your insert. I'm just going to stick with left corner because that's typically how I would have set that tool up. That would be the theoretical point for it. And we'll go ahead and hit next. So now we've got our standard pattern single pass, which is center, beginning, or end. So if you actually had a round tool that matched that, you could use center and just go right to the middle. Begin would be on the right-hand side, and end would be the left-hand side, which we're on. You also have a zigzag. I'm actually going to use this zigzag method. But first, let me go back to standard here. When you're on standard, because standard is just plunging the tool next to each other, you have different sorting options. So you have your standard sortings, just 1, 2, 3, 4, 5. Center out starts in the middle, goes one way and then back the other. Center out alternating starts in the middle and goes back and forth. And then you have skip. So it skips every other groove. But we're going to do zigzag for this one. Now, collision checking, you can use the tool holder. I don't think we'll need to in this case. So I'm going to go ahead and hit next. Step over, I'm going to just go ahead and say fine with the 50 thou. Actually, let's make it 30. Finish allowance will leave 10. And you'll notice everything else is grayed out. I can't use any of these other functions when I use the zigzag function. And then I have my rapid. So I'm definitely going to go to cycle start, X and Z. My lead in is parallel in, parallel out. I'm fine with that. And then we have our advanced feed rates and MDI. So I'm going to make sure I grab that tool. So the other method, if you do have 35, you uncheck system tool, and then you can go in and grab your tool from the drop-down list. Now for the finish, you have a forced down cutting or a basic finish. I am going to do the forced down cutting. Basic finish just goes in and then out the other side. Forced down cutting cuts on either side of that cutter to center. You do have an additional overlap, but the tool already overlaps completely because it's going to the theoretical tip. So by the time it gets here to the center of one side, it's already overlapped that tool on the other side. And now compensation, you can go with off or on with collision detection. You do have machine comp if any of you guys are using G41 and G42. I just don't run into that as often with turning. Now there's no settings for anything really here. We don't have any corners. The finish allowance is 0, fine with that. So we'll hit next. Then we've got our rapids, and this time I am going to go to home, but I might want the home to be, maybe 2 inches out in Z and maybe 2.5 in X. Actually, let's go with 3. No, I probably do want to do 4 because it's already a 7-inch diameter part. That'll clear it. 3.5, 4 will clear the part. Then we've got our leads again. So it's parallel in and angle out. I'm just going to make the angle a little smaller, maybe about 50 thou. We've got our advanced feed rates and MDI, so we'll go ahead and hit compute. Now the toolpath does look like it's a little shifted, like it's not inside of this area. So what is that? A lot of people kind of question this when they first start looking at turning. And if I backplot the rougher, and we just start moving through, you'll notice it's because of where the theoretical tip is on the tool. So by the time it gets to the bottom and it's inside of the part, it's actually not inside the part. See, it's still leaving that 10 thou allowance all the way around. So if you see that, don't be too worried. It's exactly the way it's supposed to be. And if I show you the finish, it steps in and it's getting that full radius, steps over, and that theoretical tip has to be that far out for that tool to actually contact the part. So don't be worried when you see that stuff. Now, if I want to use these same tools for another part, maybe I do these a lot. And, actually we'll probably set this up for a different part here. Let me look at, let's do a real basic OD turn with some grooves and a drill. Get rid of what's here already. Maybe we'll do some threads on here. One of the things that you can do is you can create templates. So if I use the same tools for this job as I do another job, I can save that template and use it again. So let's go ahead and start this job. Let's do turning, stock wizard. Now, when you click stock wizard, like I said, it's going to give you this work piece. I don't want to select one. I'm just going to hit next. Then we got to define our diameter. So it's it looks like 2.5, 3.5 or so, 4.5, 4. Oh, it's like 5. Yeah, 5 inch. And then length, let's say 4.25. And stock origin, we'll bump this out about 30 thou. Actually, you know what? I'm not worried about facing. We're going to leave that alone. And I don't need to change my machine setup for clearances. So I'm going to go straight to lathe turning, select geometry. And again, I just want to click the first entity and then hold shift and pick the end of the last entity, and it'll pick all the ones in between. I want to turn to OD, region 1, and I want to just get rid of primary undercut. So that's grooves on the OD. And we're going to go from stock, and let's just extend it a little bit. I wanted to do cutoff and stuff on the last one, but I've spent a little bit more time on it than I expected. So we'll do a rough and a finish. We'll do separate moves. Now let's go with this basic tool first, and then we'll change it for the finish tool. You might as well go and show offset. This part won't show too terribly great of what it looks like, but at least you'll see what it does. And we'll just keep it on standard. Depth of cut, let's make that 30. And I'll leave 10 and 10. Exit, we'll go to X and then Z, or Z and then X. Yeah, X and then Z, I'm sorry. And as long as it can go, well, you know what? We're going to go 1 inch out, and then it's about a 5-inch diameter, so we'll say 3 inches in X. That way it just moves out so we can change the tool and come right back in. A parallel in is good, and again, I'm going to do vertical out. Advanced feed rates, MDI, we don't need. And then we've got our basic finish. So this one I am going to change the tool. And now if you don't have a tool already defined in your tool crib, you can just change it here. So I might use like a VNMG, maybe 1/8 thou radius. And it just updates the tool label and everything. If you already have one in your tool crib or in your tool library or tool crib, you can go up to crib to pick it. Now we'll do a continuous pattern for this one. And actually, you know what? I like the alternating on these. It's really good on those walls. Finish allowance I don't need. I don't need the rapids. And we're going to leave to cycle start. We'll do the same thing. We'll say 1 inch and 3. And then the lead ins we'll do, lead in and lead out we'll do parallel and vertical. And then we don't need our last 2 pages. So we'll go ahead and hit compute. So you can see it's offsetting that entire path. Now, personally, I probably wouldn't do that on this kind of part, but kind of going through some of the extra things that you can do without those can cycles. So you can see it's doing smaller passes initially, offsetting all the way down following that pattern. It's weird how the simulation's kind of stopping the end of each path. So I'll speed that up. Now you'll notice that tool is turning red a little bit. More than likely, those are actually not collisions. And if you notice, it's because of this VNMG. If you look at that tool, right now they're just not being rendered correctly. And the theoretical tip is kind of inside of where the holder is. But if you draw your own holders, you'll be able to avoid that. Now for drilling, let's see what this diameter actually is. I'm going to go to evaluate and measure 1. So this is at 800 thousandths, so 160. Or 1 inch 600, sorry. Boy. So cancel. Go to our cam tree. Now we're going to do this in a couple operations. So we're going to do this in a drill. So I'm going to go to lathe hole, select geometry, and you just pick the depth you want to go to. It actually doesn't know the diameter you're giving it. We have to specify that. So I'm going to say I'm just going to go in with a 1 inch diameter. That'll keep this pretty easy. And it's a through hole, so it's going to add 50 thousandths to the total depth. So we'll pick the hole template, and I'm actually going to get rid of the center drill. And we'll hit next. Now I usually do can cycles on drilling just to keep it a little condensed on the code. It's already got my 1 inch drill. If I need to change anything, I can uncheck system tool and then click modify tool. Because if I'm using like say a spade drill or something, you might have an angle like 150 or 165 or something like that on your point. And then your use cutting conditions. What this does is it applies that extra 50 thousandths, and then we calculate for the overall depth that includes the tip angle. So when you're seeing your effective depth, that is to the depth you've defined plus the 50 thou if it's a through hole. And then the overall is your included point angle on everything else. And then we'll do pecking. It does do a default peck of 50% of your tool diameter. You can override it. So if you need to do, maybe a 1 inch peck on the first peck and then 1/4 inch on all the others, if you have that set up in the can cycle, it'll let you do that. Which actually, let's go half. We have our rapids, and I'm just going to have this go maybe 1 inch out, 3 inches in Z and X. And then I don't need the MDI, so I'll go ahead and hit compute. Now I've only drilled that to a 1 inch diameter. So there's a few things that happen when you're doing ID work that we run into all the time. So I'm going to go to lathe turning because this would not just be a regular bore operation because I have 600 thousandths worth of material that I need to take out. So if I do an ID turn, if I leave the constraints from stock, it's going to think that I have this full 800 thousandths worth of that radius to do, which is not the case. But I'm going to leave it like that for just now. And I'm not too worried about an extension, but we'll add one. Rough and finish. And the reason I'm not doing this as a boring operation is because boring is just one pass in and one pass in down to center and out, or whatever configuration for your can cycle is. So let's just go to tool crib. Let's see what we can find in here. Let's just go with a DNMG and we'll just say we're using that for both. So that's going to be, got to go back and modify that tool now because I didn't change my insert orientation here. Actually, I got to do it under tool crib, sorry. So that needs to be, in this case, 8 to go into the ID to turn that. And that holder might even be too big. I might even have to go in and modify that tool. And I'm just going to leave it all standard. I'm not going to be worried about the tool depth of cut, the overlap, any of that. It's just a straight hole. And we'll maybe move out to 1 inch and Z and maybe 0 and X. So it just changes tool and go right back in. And actually, we're probably going to need that to go to like 5 and Z. So we've got our lead in parallel, do vertical out, which it will go down, even though it's showing up here. And I'm going to shorten that length to maybe, let's say 30 thousandths. You'll see why here in a moment. And then the basic finish, we'll just go with that same tool. And it was the DNMG orientation 8. At least that's what it should have been. Ah, I didn't pick that one. Okay. I thought I did. My bad. Picked the wrong tool. All right, there we go. Now we got the same one. So continuous pattern on without collision detection for the compensation. Don't need anything on this page. I could use the chip break if I need to break it up in that hole. And we'll bring Z out to 5 and then X to 0. Actually, let's bring it up to 3. And then we'll set our lead ins, and then we can just take compute. We don't need those last 2 pages. So you've noticed, because of the constraints, it's doing the entire ID. I don't want to do that, of course. So there's a couple different options. The first one is just using custom. If I put in custom here, and then I tell it, I've already taken out 1/2 inch of that. So if I do 0.8 minus 0.5, I have 300 thousandths worth of material I need to cut. I hit compute, and it reduces that down. Now, some of the things that will trip people up is this retract here. So there's 2 things. There's your lead out, which I already changed the length of. I don't think I changed it for both of them, though, so let's double check. 30 thou there, and I didn't change it for the lead out on the second one, so I think I caught that first. But your rapid plane affects a lot of things here. So if you need to be a lot closer to the part, that might need to go down to about 50 thousandths. Make sure that you're not crashing into anything on the opposite side of the part. Now, I believe this tool is probably going to be too big, so let's just do a back plot. Yeah, that's going to be crashing into the other side before it even gets there. So we want to edit that tool. Now, if you're in version 35, I can go to my operations tab. Now, I've moved mine to the right-hand side of my screen. For most of you, it's going to be on the left. If I go to the tool tree portion of that, I can go to the DNMG, right-click on it, and go to Edit. I go right down to my tool holder, and then I can change these values. So let's say A, we're going to go, now A shouldn't matter too much. C and B, okay, B, let's go down to 3/4. Shank width, let's go to about 3/8. And then this one shouldn't be affecting it that much. Why is there so much of an angle? Oh, that's right. All these tools are kind of goofy right now. You know what? Let me add a geometry for a tool. So let's cancel this real quick. I'm going to go to a new file, and actually let me just drag it in. Just had it on my screen. Where'd it go? There we go. Now I'm just going to use this holder here. It shouldn't really make too much of a difference. Well, actually, no, I can't use this holder. Not for that. Not for the ID. I might just have to change the tool altogether, because otherwise it's always going to show that it's colliding with the backside. So let's change this to a C. And even these are showing like that. That's odd. Yeah, that's not showing right at all. Huh. Well, let's see what that looks like in simulation. Now, once I change that tool here, I notice these little dirty flags here, the exclamation points. We have them all in our CAM tree as well. That just tells me I need to recompute that feature. Now, I can do it from the tool, I can do it from each feature, or I can do it from the feature level itself. So we'll compute. Now, I'm not sure what that tool is going to look like in simulation, but let's go ahead and check. I do know anything that's not a CNMG kind of looks funny currently. Now, I've already seen the first operation. I don't want to see that one again. So if I go to front, I'm just going to click lathe drill. Now, obviously, I can't see through that stock. So one of the tricks I use is if I go to visibility, I can change my stock to transparent. That way I can see what the drill's doing in each of those movements. You know, there's my first depth, and then there's every depth after. But I can also see what the ID tool is doing as well. And that ID tool should be coming up here in a second. Yeah, see, they still are looking kind of goofy. Now, I wonder if I had picked it as a CNMG first and then modified the holder. So let's just change the tool and try it that way. Currently, I know that that's kind of goofy here. So we'll just go to the finish category. I'll grab the CNMG 164, and we'll just modify the holder here and see if it changes. So let's make this the recorder. It should be fine. And the shank width, bring that down a little bit, and it could be bigger. So we'll compute those. Now, I could have left the simulation open, actually. In version 35, we made a lot of improvements to the way the simulation works. So now you can actually leave it open and then modify your tool as you go. So all I got to do is rotate the tool. Let's go ahead and do that. Edit. I'm not going to be able to do it through here, though, am I? Nope. I have to do it through here. And orientation 8. Go to the finish, tool crib, finish. Orientation 8's already picked, so we'll do that. Hit compute. Now, if I hit start simulation, it just reloads it. You notice that was really quick. They made quite a bit of improvements to that. I really like just leaving the simulation open when I'm just making these quick edits. Makes things a lot easier. So that looks a little bit better. I could still probably modify that A value a little bit. Now, a lot of these little red marks that look like collisions to the simulation aren't actually collisions. It's just cutting on the back end of the cutter. It just didn't expect to. ModuleWorks, the simulation, often sees it that way. And sometimes it's the way that it renders the holder. So if you zoom in, sometimes you can see where it's colliding. So those are actually not real crashes, so I wouldn't worry about that too much. And then there's our finish pass. Now, the other way that you can handle the ID for that, and it comes with a lot of other problems, is let's say I wanted to go from stock and that was just what I was used to doing. You can turn on trim to stock. And this is actually better for OD operations personally. You'll notice it's actually looking at the actual tool geometry there. Now it should have gone beyond that. I don't know why it didn't go beyond the 4 inches. I defined it total depth as 4, and it was going past 50 thou, so interesting. But you can see where it picked all that up, but it's going down to center when it retracts. And even if this was all cleared out, it would still be doing the same thing. So keep that in mind. Trim to stock does not really necessarily work very well on the ID of a part. It's more suited for the OD. So really for ID work, you want to go from custom, you enter the remainder of the radius, and don't use trim to stock. And that should just give you the exact amount that you need. Now I'm going to do these grooves. I can do these on the same groove feature, like I said earlier. Now I didn't measure the width of these, but I'm going to just go in with like a 118 and hope for the best. So I want to go from geometry. We're doing OD, rough and finish. And I generally like to use can cycles for grooving, especially if they are square grooves like this. It just gives you a lot less code. So let's say we go with a 118, and the radius, let's just go with like an 8 thou. Next, we'll do standard with standard sorting. Step over, now let's do 60. And we want to go to cycle start. We want to do X and then Z. And we can't change our lead ends. Maybe make our length a little bit shorter here, maybe about 50 thou. Then we have our advanced feed rates and MDI, which we're not using today. And I want to just make sure I grab that same tool. So I'm just going to uncheck system tool and grab it from that little drop down. Again, if you're on version 34 or under, you do have to go to tool crib to pick it. So force down cutting, I don't need an overlap, and it's already got the system comp on. And really, I don't need the parameters. There's nothing there for me. The rapids, I can just have this go home so it can change tools. And then the leads, I'll just shorten this a little bit. Then I can hit compute. So I'm doing both grooves here. Now, we haven't talked about it yet, but let's do a little bit of threading. We'll maybe thread this first portion. I'm going to right-click machine setup one again, and I'll go down to lathe thread. Select geometry, and just pick this guy right there. And next. Then we have our rapid plane, our feature type, and our region. And we also have extensions, which I'm not going to use in this case. You only have the one operation, just lathe thread. And I will use can cycles. Now you have your two different thread options. You have your lay down and top notch style tools. I'm just going to go ahead with the top notch. And it is going to be a 60 degree. You do have all your different styles in here, 29, 30, 55, 57, and 60, which I know there's more than that, but it's what we have. And the width, let's make that, 125 should be fine. And I'll look at my tool holder. So I don't want my tool holder going this way. So, and I knew that, I kind of figured that was because if you look at the label, it says ID thread. So I need to go to tool crib. It picked the wrong orientation tool. So I'm going to go to top notch 60 degree. That should give me the correct insert type. So it's a good thing to check that tool holder every now and then. All right, so to define the thread, you're actually just going in and defining the threads per unit. That should calculate out the rest. So if I'm doing a 1/4 20 or 3/8 18, it should calculate the pitch and the thread height for me. You can override the thread height. I found that depending on the thread you're doing, you may have to adjust that a little bit. Now, depending on your can cycles, your first cut amount and the last cut amount may not be first and last. It might be uh, minimum and maximum cut. It could be just you use the first cut amount. Every can cycle is a little different. That's just the way that we refer to them here. And then number of finish passes, depending on your can cycle, it may just do one last pass at the 30 thou, or it just may do one remainder pass. You can have it do number of finishes, and it should run a couple of them at the same depth. But that's what that is. And then your thread in feed angle, typically you match it to your thread angle. And then can cycle chamfer out, we're just going to leave that off since we got those groove reliefs. Then we have our rapids. I'm just going to leave this default. Actually, let's just do, yeah, we'll leave that default. Oh, and then the leads, I don't need 250. Let's just go with maybe 100. And then the lead out, I'll just go with 60. And I don't remember how big those grooves are, but if I did 118 and did a couple passes, we should have plenty of room to do that. And then I don't need my MDI, so I'll go ahead and hit compute. Now your threading will show as these little up and down movements. It's going to look like that in simulation. The reason for that is because we're not actually spinning the stock in simulation. It's actually staying stationary. So when you're actually seeing the simulation run, the stock's not moving. So in order for us to simulate there's a thread, we just have the tool move up and down. Obviously, that's not what it's going to do with the machine. It's going to run as many passes at your depth of cut till it gets to the thread height. But let's take a look at the way it used those values. Now I'm using the single line basic post. I'll change it to a couple of different ones. But if I post this, just that one operation, I could see it's using the depth value, the D. And it looks like that's it. There's my in feed, finish passes, my feed rate, the Z depth, X diameter. There is no last pass amount. So even on this can cycle, that 30 thousandths didn't even get used. So just keep in mind, those are going to be varied depending on your post. For instance, I think if I use the Haas post, it's the same way, if I'm not mistaken. Oh, I don't want to post the whole thing. Post just that operation. Yeah, so that one's just using that D value. Oh, no, it's using the 60 there on this one. But it's a, yeah, and there's the total depth. So it's starting at 60, never mind. So yeah, that 30 is not getting used. So even on the Haas, it's not. So keep that in mind. It uses it differently based on your can cycles. Now, if you're using the G32 separate moves cycle, they use them as they're written. So every pass would be at the 50 until it got to the last, which would be 30. So let's go ahead and do a cutoff. Now I have this tree is starting to build up, so I'm going to minimize some of this. Right-click machine setup 1, and we'll do lathe cutoff. So I'll select geometry, and I just want to pick where I'm cutting off. That's going to record the X and Z position of that value. So I want to do OD, but if I need to do any corner breaks, maybe I need to do a radius or a chamfer on the end of this, I need to do custom. If I leave it from stock, it's actually going to do the corner break way up here. And you can even see that in the preview here. So I need to change this to custom, but the value, I need to pick where that new diameter, where the new diameter is. So it's 200, 400. So next. Then we have our cutoff operation, just like threading, it's the only one. And I'll do separate moves so we can see all the options we have available. Now it automatically picked the 118. I'm actually going to go and do a different tool, which that is not at all the one I would want to use. We'll go to cutoff and add from library. Now I want to take a look at this one. So I'm going to expand my tool parameters. And this already has quite a bit of relief on this, but if I edit the tool holder, and it's only 1 inch 625. So I need to make this a little bigger. Now I do have the 1 in 600 thou 1 inch 600 hole down the middle, but let's make that about 2. That way I should be able to do the whole thing. Let's go 3. So now I'm going to go ahead and select that tool for use, and I can see it oriented correctly here. So I'll hit OK. Now you do have your RPM and constant surface speed. I know I haven't mentioned that yet, but most people I run into, if they're doing a lot of different diameters, they're doing constant surface speed. I don't know too many people that stick to RPM, but you have both options. So the cutoff is at the Z depth here. If you're comping the tool on this side, we take the width already in consideration, so you don't have to worry about the width of the tool. We handle that for you. I know that's usually the first thing on people's minds when they're learning to use this. And then the X position is just that 800,000 cutoff, but I'm actually going to change that. Let's make it 0.6 so it goes beyond a little bit. I'm going to add a chamfer, and we'll just make it, I don't know, 62,000. Now we're just going to let it do the default rapid, and we don't need our MDI, so we'll hit compute. Now, if I blank all these and click on cutoff, I can see that that tool is going beyond, and that chamfer is happening up here. So the way this tool moves is it's going to go in first, plunge to the depth of the cutoff or the chamfer, then it's going to retract, move over, and then apply the chamfer and then cut off. Now, if I use these tools all the time, now I wouldn't use that ID tool because that I probably messed something up there. But if I use this same setup all the time, maybe I don't use the same stock, but I use all the same tools, I can right-click Turning Job and go to Save Job as Template. This is one of the things we introduced a couple years ago, and I'm just going to call it Turning Job. So if I go and add another file, let's just bring in a different document here. Let's say I do this one here. So this one already has a bunch of features that took off a bunch of stuff, which I'm not going to do any of these. Let's just delete the job. So if I load the job from template, now again, you do have that under your CAM tab. Up here, job from template. You have the job from template on the CAM tree, little quick access bar. And then if you right click CAM defaults, you have job from template here. So I'm going to do turning, and I have turning job as my template. Now, if I click Stock Wizard, it's going to start out right away for my workpiece. I'll just hit next. And I don't want to revolve stock. This is using the previous stock that I had defined when I saved this as a template. So I'm going to go to revolve. So I should be able to pick this stock there. That's my revolve stock. I just hold shift and pick that, and we'll calculate it. And that's giving me the exact stock of that model. Hit next. And then I have my clearances, so I'll hit OK. So it's already got all my operations that I just defined earlier. So if I needed to use that same groove, I'm using that 118 groover, I just reselect the area that I'm doing. Now I have to change it from can cycles, but I can still go from geometry. I just want to switch to separate moves. And now it's grooving that one. My OD turn. I can pick my geometry and pick from here, here. And the only thing I need to change on this one is now this is actually where the trim to stock comes in. Actually, let's just go ahead and hit compute and see. And I do want to get rid of that offset pattern, but you'll notice that it's doing the entire area that this stock would be in, because when you use from stock, even though this is the stock I defined, that may sound confusing because I did define the stock as a revolve, but it doesn't read it that way. When you say from stock, it takes the bounding box of the definition of the stock. So it's actually looking at this as a big rectangular area. So what we need to do, this is where the rough or the trim to stock comes in. So as long as I turn this trim to stock on, it should only cut where there is stock to cut. And I want to get rid of the pattern there. So let's change that as well. So let's do standard. But now it's only cutting where I have material to cut. And then that hole, it's not going to be a 1-inch drill, so I don't even need that feature. I can even just delete it. The Geometry, the ID turn, I don't need that. I can get rid of it too. And if you relabel these once you define them, it makes the things a lot easier too. Lathe thread, I could do a thread on this one, but I don't need it. I could delete it. But it's got all my same tools. Everything I did on the previous job is all there. And then the cutoff, I can pick that, say endpoint. I just want to go right down here, compute. Now it's using the previous value for the stock diameter because I had it set to custom. So it's things like that that you'll have to adjust, but my custom value here now is going to be this value instead. So it's just little teeny changes to the program and it fixes up everything. But by saving that template, you can shorten up, I'd say probably about 90% of all turning jobs that you do. Most turning jobs, you're doing a OD, ID, maybe a thread, cutoff, maybe a groove. It's a lot of the same stuff. So if you define one of these templates, you can save yourself a ton of time of just building out your features and pulling in your tools because it's already all there. There's also a couple other settings. Yeah, my tools still drawing funny, but that's only because of the tool that I'm using. Oh, and it did pick the other one, so I'll have to go back and change my groover. But some of the other things, for instance, let's say on an OD turn, maybe on an OD turn, my depth of cut is always 30 thousandths, and maybe I only leave 5 thou in X and Y. I can hit save defaults, and I can save that for just the rough. I could save it for a new template. So I have a settings template as well as a job template. So the settings template would be different settings that you save as defaults. So if you go in, maybe you have a job that you're running, plastics versus, titanium or something, you can have in those template options so that you're able to quickly switch between different materials rapidly, or just different types of jobs rapidly. Yes, Travis just mentioned the template options. Those tool numbers don't always carry over. However, Travis, if you're in version 35, they should. So if you're seeing that, let us know. Show us a little bit of call our support, show a file, something that kind of shows that where we can get it over to development. I do know that if you copy and paste a job and you've turned off the new setting in 35 for and I'm can never remember where it is. I want to say it's in the default tool numbering. It's under the job, the document default and current document. If you set the automatic tool numbering to be off and you copy and paste the feature, it also doesn't carry over your tool numbers. I do know that as well. So keep an eye out for those little things. But besides those minor details, those templates save tons of times. I mean, this is primarily 90% of the jobs that I've done turning. Drills are usually easy to add. I don't typically add those through the templates. The other thing you could do is you could just make a job without stock defined, load all your tools and make that a template. So whenever you start a new job, it's just has your tools. That way you're not having to load a crib every time. Now, a couple of the other things that wanted to talk about, getting on tooling a little bit. Now, so just kind of going through some of Al's points on our best features kind of page for Lathe right now. So we have these flyout menus. We have them for all modules. Now, each different menu is going to show you different options. So if I need to change my speeds and feeds really fast, I can change them right here. If I need to see how long that operation is going to take, I can see that right here. If I go to the feature level, it shows me different operation stuff. So on an ID, I can change my rapid plane pretty quickly. I can change its separate moves of can cycles pretty quickly. Machine setup, it's going to show me my clearances. I can change those on the fly, as well as the stock. I can see the size. Tools will give me a list, which you'll actually get your tool list now in the operations tree as well. So I can see tools that I have in this job saved from the template, but they're not actually being used. They don't have any operations on them. And then you have your job level where you can change your program number. This is one that I really like. I've been to a lot of shops where they had to go in and edit every single job because they didn't want to change the program number because it was a little too daunting every time. This has saved them a lot of time. Just that little minor thing. You know, you can change your program number here, and when you post out your code, you'll see it at the top of your program. Now, I did want to go through some more stuff with tooling. That was about it. I wanted to go through on the toolpaths and some of the toolpath options. You know, we touched on the chip breaking, the separate moves, you know, turning separate moves off, having a little bit more options. Things like that can save you a lot of time, can enhance your experience cutting some of these parts. But getting the tools in the system sometimes is where a lot of people get stuck. So if you are a member of Machining Cloud, one second. So if you are a subscriber of Machining Cloud, they do charge nowadays, I believe. There is actually another website that I found that if you're only using Kinemetal tools, I definitely recommend this one. It is the Novo Kinemetal browser app. This is the same thing as Machining Cloud. You can load up your tools, but it's only Kinemetal, but this one is free. So if you wanted to simulate better tool holders and everything, you absolutely can. Now, I already have a couple of these downloaded from previous jobs. Just got to find them here. So what happens is they'll send you a zip file. So in that zip file, I'll just go to my CAM tab and I'll go to the tool library. So when I'm in the tool library, we have this import from file option. You've probably seen it in a lot of versions, but a few versions ago, we added the new drop-down option for the Machining Cloud zip. So I'm actually going to just, I'm going to have to go to that file location. Bear with me, it's through a bunch of folders here. There it is. So this zip folder here, when I hit open, it's going to show me these tools. So mine came in fine. They actually came in black text. If they come in red, that means that there's something that needs to be fixed on it. So it comes in with a holder and the insert. I can assign what category that insert's going to. So if I scroll down, it's not going to show me the holder here right now. If I go to the groove, I think it's the same thing. Yeah. But if you know the model number of the holder that you got, they'll show in here. But each one of these, you have your different grooves. I'm going to set that as a groove. And this one is a boring bar. I'll actually set this as boring. And I'll hit save. So now in each one of those categories, so if I go to lathe and go to boring, I have the new boring bar. And there's my tool holder and everything. Now I can't edit this holder. And the nice thing about this holder is let's actually go back to this guy. So that tool, I'm going to change that tool. So again, I'm going to use this guy over here. Let's just find which one it is. So if I click on the feature on the actual tool, it should highlight what it's doing. So there's my ID tool. So I'm going to right click on this and replace. And we'll go to boring and boring bar. Now I'm probably going to have to go into the operations next and change the orientation because it's going to be in this orientation here. So keep that in mind. You'll have to go in and change it. Help if I was in the right category. But you'll notice it is a round boring bar. Double check the holder. Looks good. So now let's check simulation. So that is going to be, let's back it up one. Restart. We'll do the drill and then we'll see what happens after. And I don't see any collisions, so we're looking pretty good. But that's the only way you can simulate a round boring bar. And yeah, I need to change that grooving tool, but That came in really clean. That tool looks great. So the other tools, let's go ahead and take a look at what those look like. So I'm going to go to lathe turning since I added one in that. So I believe it was under the rough category. And there it is. So I'll hit OK. And that's actually got my holder and everything on it. So I can actually see the real physical holder that the actual tool has. Make sure that picked the right one here. No, it did not. Didn't think so. That looked a little funny. And the finish, I'll go ahead and pick a different tool, pick a CNMG. Maybe you just use that same one. And I've already got my stock transparent, so we'll just skip ahead. One more, there we go. Oh yeah, I wanted to see the rough tool. So let's go to front and run. Yeah, even in length mode, it still runs fast, but you can get it to a point where you can see the full travel of that tool. Now that pretty much wraps up everything that I was planning on going through today. So if any of you all have any, oh, actually there was one more thing I'm going to touch on, but still invite you all to ask any questions. I know Mike D and Al, I believe, are in the chat as well, answering if you guys need stuff. But feel free to ask any questions, and I can touch on any of them. But I am going to show one more thing before this. So if you're not subscribed to Machining Cloud, if you don't have just Kennametal tools and you can't use that site Novo, you do have the option to draw your own tools and holders in the system. Now, there is actually a really good help system document on this topic. I definitely recommend, if you have to do so, double check that document, for different methods of selection and everything. But if we go ahead and close this out, and I did want to see what that last tool looks like. I think it was a grooving tool, if I'm not mistaken. Yeah, so that's the holder that it has. So it's a little bit more specific to that actual holder. So I want to say, yeah, that should be the one that just got added. And then they should have surface footage, everything. So it's using Kennametal's all recommendations and all that. So just be careful with using the Machining Cloud if it's got speeds and feeds already set. They may not be suited for you. Now, the last method of loading in a tool is actually drawing it out yourself. So it already opened the file once. I'm going to bring it back in. I did have it. There it is. So we used to not have the neutral holder insert orientation. That's why I have this as my example. Let's just double check. There is layers here. So my CAD layer is the insert. So when you're defining a tool, the insert is the solid edge is actually the cutting edges. The dashed circle is your mounting position, and you have your theoretical tip. So in the holder, you'll have the same thing. You'll have your outline of the actual holder, and then you have your mounting position. The mounting position is where they're going to both meet up. Now I'm doing this in a new file because you have to go to your CAM and tool library. You can't do it under a job. You have to do it under the library, under the defaults. So I'll go to lathe, and we'll just say rough. Actually, let's do this under finish, and I'm just going to add a tool. So when you add a tool, I'll expand the parameters. New tool. I'm not going to get too creative with that. So it's a custom shape. So I select the custom shape option and then I hit assign tool insert. And if I have the holder layer off, I can actually window pick all this. And you'll notice it doesn't look like I picked the dash line or the point, but over here in my data entry window, I have my insert shape, my match circle, and then the reference point. That reference point, your theoretical tip. Where you put that is where it's always going to be. Where you orient your tool is how it's always going to be oriented. As far as this goes. So keep that in mind. You cannot change to center or tip once you've picked that reference point. You have to define a new tool. And I'm not using that holder, so I'll hit Edit Tool Holder and then click Custom and pick Geometry. So hide the CAD, show the holder. And again, I can just drag a box around this. I have my holder shape and then the match circle. So selecting your tools and all that, you can draw them up. If you do have options of using the Kinemetals Novo site, go through that way. But if you have a subscription to Machining Cloud, you're going to have a lot more tools available to you. Just know that some of them do import in with a little red text when you import them. If it's red text, that means one value, at least one value, could not have been resolved. And it's just how the manufacturer defined the tool. Usually it's just one value that'll say all nines. You change it to what it's supposed to be and it resolves it. But yeah, we're going to open things up for Q&A. Thank you guys for joining us. That's pretty much everything that I wanted to touch on today. I don't think there was anything left out of this list of stuff, but any questions you guys have, feel free to ask. I will be right back in just a couple minutes. So, Travis, this is actually a new platform for us. I believe it's just immediately being linked. I don't know. I have to get with Al. He's usually done the Vimeo stream before, but normally we post them on YouTube afterwards. But the way we were doing it before actually took a little while to get to them. But if you check out our YouTube channel, we actually have a bunch of them already listed. And in fact, let me just pull it up for you. Mike just sent me a link for it, actually. So this is where it's streaming from. And I guess, but that's the live. Where do you see the recorded? Is it just immediately posted after this, Mike? I don't remember how Al explained all this. If you go to YouTube, yes, it should be posted right after this immediately, I believe, because it's actually live streaming straight to a bunch of platforms. So it should be up immediately. But if you want to go back and look at, yeah, you can even see it streaming live here. If you go to our playlist in YouTube, you can find the training events. So if you have Rhino, the BobCAM for Rhino, BobCAM for SolidWorks, or our standalone, we have all of our training events already posted up here, where you can look back at any of them. And if you click the view full playlist, you'll see we have quite a few in here that are linked up. So tons of content to look at, and this one should be put up there just as quick. Oh, no problem. Thank you for asking a question. Like I said, we'll be here for another few minutes or so. If anybody has any questions, if not, we still thank you guys for joining us. And for anybody else that's still in the live stream, might as well show you guys some things here. We have our BobCAD user forum. If you're not a member, please sign up. You can get in contact with us all the time. A lot of us don't have lives, so we just kind of answer stuff on the weekends and nights and middle of the night sometimes. So if you have any questions, this is another good way to get a hold of us besides support, email support, or online training. Which online training is always a great option if you just need help going through a specific part. One of us can set up an hour or two going through either drawing up a part or actually programming the whole thing, depending on what it is. But if you need more specifics than the live events or some of the resources that we have on our support site, we do have online training available. If you go to bobcadsupport.com, you can find our link to Launchpad, which is our new online education platform. So if you're looking for additional training, this does have little quizzes to go along with all the lessons. We've been working on this for the last year or so. We're building more on it and look forward to adding more constantly to it. So working on a new mess of videos and such right now, actually. And if you have any recommendations on things that we could add as lessons, feel free to add that into the chat here or onto our user forum. We definitely love the input. But again, we're going to be here for Q&A if anybody has any questions. All right, everybody. Thank you all for joining us today. That does it for us.